What if tomorrow morning, scientists discovered something moving silently through deep space? At first, it looks like nothing. Just one tiny dot on a telescope image. Small, cold, almost invisible. But then the computers begin checking its path. Again and again. And suddenly, the room goes quiet. Because this dot is not just passing Earth. It is coming straight toward us. Inside a space agency control room, scientists stare at the same calculation. The orbit line does not bend away. It does not miss. It crosses Earth. And then the final result appears. Impact probability, 100%. This is not a small meteor that will burn up in the sky. This is a giant asteroid, several kilometers wide, moving faster than a bullet, carrying more energy than every nuclear weapon on Earth combined. And the worst part? It is already too close. For most of the world, the day begins normally. People wake up, go to school, drive to work, scroll on their phones, buy coffee. Nobody can see the danger yet. The sky looks normal. The sun rises like always. But behind locked doors, scientists are facing one of the most terrifying questions in human history. Can we stop it? First, they need to be absolutely sure. Telescopes around the world turn toward the same tiny object. Every new image confirms the same nightmare. The asteroid is real, its path is real, and Earth is directly in its way. Scientists estimate impact in 6 months. 6 months sounds like a long time, but in space, 6 months is almost nothing. If we find a dangerous asteroid many years early, we might be able to gently change its path. A tiny push far away from Earth could become a huge miss later. But this asteroid is huge, and it was discovered late. Now humanity has a target and a deadline. At first, governments try to keep the information quiet. They need more data. They need a plan. They need to avoid panic. But a secret this big cannot stay hidden for long. An amateur astronomer spots the object. Then another. Then someone posts the orbit online. Within hours, the story spreads across the planet. A giant asteroid may hit Earth. At first, many people refuse to believe it. Some say it is fake. Some say scientists are exaggerating. Some say it will miss. But then, the official announcement comes. A global emergency has begun. The asteroid is given a scientific name, Object A-17. But online, people call it something else, the Earthbreaker. Now everything changes. News channels run non-stop coverage. Supermarkets fill with people buying water, food, batteries, and medicine. Families call each other. Schools close. Airports become crowded. And millions of people look up at the sky, even though there is still nothing to see. So what would actually happen if a giant asteroid hit Earth? To understand the danger, we need to understand energy. An asteroid is not dangerous because it is on fire. It is dangerous because of speed. A large asteroid can travel tens of thousands of kilometers per hour. At that speed, even stone becomes a planet-shaking weapon. The first defense plan begins immediately. The idea is not to blow the asteroid into pieces like in movies. That could create many deadly fragments. The better plan is deflection. Change its path slightly, so it misses Earth. Within weeks, the first mission launches. A heavy spacecraft is sent toward the asteroid. Its job is simple. Crash into it at high speed. Push it just enough to change its orbit. The world watches the mission live. For one moment, almost all of humanity is focused on one tiny machine flying through darkness. The spacecraft approaches the asteroid. Closer, closer, closer. Impact. The signal disappears. Dust and rock explode into space. Scientists cheer. The asteroid moved. But then, the new tracking data arrives. It was not enough. Earth is still in the impact zone. The second plan is more extreme. A nuclear device is prepared not to destroy the asteroid, but to explode near its surface. The goal is to push it with a powerful burst of energy. It is risky. It has never been tested on a real asteroid this large. But now, there are no perfect choices. The mission launches. Days pass. The world waits. Then, far away in deep space, a bright flash lights one side of the asteroid like a tiny artificial sunrise. Everyone waits for the new orbit. The numbers update. The asteroid has changed direction again, but still, not enough. The impact point shifts. Millions of lives may be saved, but Earth is still going to be hit. Now the world enters the final month. The asteroid becomes visible through powerful telescopes as a moving star. Every night, it grows brighter. Governments begin evacuating possible impact zones. Coastal cities prepare for tsunamis. Hospitals move supplies inland. Shelters are built, reopened, and filled. Scientists release survival instructions. Stay away from windows. Move away from coasts. Store clean water. Prepare for darkness. Prepare for cold. Prepare for the sky itself to change. Then comes the final week. Now ordinary people can see it. A strange bright star in the night sky. It does not twinkle like a normal star. It moves. The world becomes quieter. Some people panic. Some people pray. Some people try to escape. Some people spend every possible moment with family. BYTE watches children looking through a telescope, not fully understanding what they are seeing. Because the scariest part is not only what comes from space, it is what happens after. Then the final day arrives. The asteroid is no longer a dot. It is a glowing object in the sky. At first, it looks almost beautiful, a bright scar of light above Earth. But beauty turns into terror. The sky grows brighter. The air begins to shake. The asteroid enters the atmosphere at impossible speed. A glowing shockwave forms around it. Clouds rip apart. The ground below lights up as if a second sun has appeared. Then impact. For a fraction of a second, the asteroid and the ground become hotter than the surface of the sun. A crater opens in the planet. A fireball rises into the sky. A shockwave races outward faster than sound. Minutes later, earthquakes travel through the crust. Hours later, tsunamis slam into coastlines. And then, after the violence, comes silence. The sky turns dark. Not night, something deeper. Dust and ash spread around the world. Days become dim. Temperatures begin to fall. Crops fail. Flights stop. Communication becomes difficult. Satellites watch Earth slowly turn gray. But this is not the end of Earth. Earth has survived asteroid impacts before. The real question is whether humans can survive what comes after. Clean water matters, food matters, shelter matters, communication matters, and science matters more than ever. The survivors who prepared inland have a better chance. Communities share supplies. Engineers restore power. Farmers grow food indoors. Scientists study the atmosphere, the oceans, and the temperature. BYTE walks through a world that looks broken, but not defeated. Because even in the worst scenario, humanity still has something powerful. Knowledge. We know how asteroids move. We know how to find them. We know how to calculate their paths. And we are learning how to change those paths before they ever reach us. The real lesson is not that space is terrifying. The real lesson is that early detection can save the world. A dangerous asteroid discovered decades early might never become a disaster. A tiny push at the right time could turn a direct hit into a safe flyby. That is why telescopes matter. That is why space missions matter. That is why science matters. Stay curious.